Hey guys, and welcome to chapter 6. We're going to deal today with 6.1 to 6.3. So you're going to have 3 small videos on each subchapter. I told you this in class. Chapter 6 is probably the most difficult chapter we do this semester. So we're going to go slower a little bit, and hopefully if you do your job and I do my job correctly teaching, we should make it happen. 6.1, we talked in class about all of the exponent rules. You have them right here. Please remember on your Google Classroom under chapter 6, you will have a sheet that you can print out with all of these properties. You should have them. I gave them to you in class. But if you lost it by any chance, it's right there. It's uploaded. All you have to do is reprint it at home and you have it. Okay, so all of these are on that sheet that is called properties of exponents under your Google. I think that's why I named it. Okay, and we've done this last year. You've done this last year. Even if you didn't do math with me, you should have gone through the rules of the exponents last year in detail, right? Let's really fast remember. When we multiply the same base, which means it's the same number, 2 to the third times 2 to the fifth, that becomes 2 to the 3 plus 5. We just add exponents when the base is the same. If we have a number raised to a power, and then we have parentheses and raised to a second power, then all we have to do, remember, we said if you remember to do this, and you remember I have to multiply the 2 exponents, I get the right answer. If I have 2 different numbers and they're raised to the same power, we can distribute that power, right? And it becomes first number to that power times the second power to that number to that power. Also, we can move on to those are multiplication rules. Here's your division rules. If you have the same base with 2 different exponents, all you do to the exponents is you minus them. So if it's all division, if it's a fraction, we minus the exponents. If there's 2 different bases, we don't do anything. If you have 2 numbers in the parentheses raised to the same power, we do the same thing with this multiplication. We just distribute this exponent to both top and bottom. Any number to a negative power gets flipped. You get the reciprocal to that positive power. And then one of the most important rules, any number to the 0 power is 1. All of these rules, you have them in your book at 323 also, just in case you want to look at them, and you have them on our sheet. Let's work some examples here with both variables and non-variables. 2 to the third, all of it to the fourth, that would be that, right? I remember I need to times that. That becomes 2 to the 12. 3 times 4 is 12, right? 3 over 4, all of it raised to the second power. Oh, it is right there, right? That means this exponent gets distributed. This becomes 3 to the second over 4 to the second, or 9 over 16. If you memorize these rules, there's no way you get confused by this with numbers. Variables, we'll talk about that. Negative 5 to the negative 6 times negative 5 to the fourth. This becomes, it's the same base. This becomes negative 5, and I just add the exponents to the negative 2. And I told you we never, ever, ever leave numbers with a negative exponent. We have to flip it. What happens? Becomes 1 over negative 5, all to the second. We get the reciprocal of that, and we raise it to the second power, or 1 over 25. Please always solve it. This is how you do it with numbers. Again, you know the rules, you can't mess up. Let's do some variables. R over, I'm going to make this an X. I hate S. X to the negative 5, all of it to the second power. This is this. So the first thing I'm going to do is I'm going to distribute. This becomes r to the second. And remember, this is to the fifth, all of it to the second. So I need to times over x to the negative 10. Why did I time it? Because I skipped a step. This would have been r all to the second over x to the negative 5 all to the second. This is just r to the second. X to the, that gets timed negative 10. Remember we said you never use a negative exponent. What do we do? If it's under the line, it goes on the top of the line. So this becomes r to the second, x to the 10th, right? In order to make it positive, you bring it to the top. If it's on the top, you bring it to the bottom. The last thing we have here is 7b to the negative third, all to the second, times b to the fifth, times b to the second. I can go ahead and take care of this. This becomes b to the 12th, right? And here I get to distribute this. This becomes 7 to the second, which is 49, times b to the 2 times negative 3, negative 6. Let's not stop. Why? I still have a b and another b. I add exponents. This becomes 49, b to the negative 6 plus 12 to the 6, right? Let's look at another example. I didn't have room, so I wrote as many as I could ahead of starting the video. The last example in the book is one that's a little bit more complicated. X, y to the second. All of it to the second power, all over x to the third, y to the negative 1. Okay, let's work this step by step. First things, this 2 gets distributed, right? This becomes x to the second, y to the fourth. Why? I can time it, right? The bottom just stays what it is. X to the third, y to the negative 1. And I can now separate it so I can have the same basis. I can write x to the second over x to the third times y to the fourth over y to the negative 1. Well, this is the same base, right? So this becomes x to the negative 1. 2 minus 3 is negative 1. And then y to the 4 minus 1, 4 plus 1, or 5. Again, we never, ever, ever keep a negative exponent. If it's on the top, because I can write them all over 1 if I want to, whatever is negative goes on the bottom. Whatever is, so this becomes y to the fifth over x to the first, or just x. Okay, so you always want to take them in order and go do the top first, do the bottom second. If you have numbers, please reduce numbers. If I would have had a 4 over, I don't know, 36, that would have been 1 over 9, right? We reduce numbers. And then you can separate them, so that way you can go, well, this is this, and this is this. And once we get here, this is this. And you can keep applying rules until that gets done. Okay? That's how we play with this. You'll have homework from your rules. My advice for you would be memorize them. You're not going to have a cheat sheet for your test. Moving on, we have a how do we do this in real life situation? Example 3 is an astronomy problem, and it says the radius of the sun is about 109 times as great as Earth's radius. How many times as great as Earth's volume is the sun's volume? First thing, what is the volume of a sphere? Chapter 1, common formulas, it's right there. Your volume is, I think, if I'm not crazy, it is, 4 over 3 pi r to the third. Okay, that's the volume of a sphere, is on your chapter 1 sheet that I gave you. So, here's what I know. Sun's volume over Earth volume. Well, what do they tell us first? Here's what we know. We know that the radius of the sun is about 109 times as great as Earth radius. So, the radius of the sun is a 109 radius of the sun, right? Because it's that much greater. So let's go ahead and replace the top volume. 4 over 3 times pi times 109 r all to the third. Why? Because the radius of the sun is 109 times the radius of the Earth. The bottom is 4 over 3 pi times r to the third. That's all you have, right? There's no difference in here. Well, there's a lot of things we can get rid of. I have a pi over 3 on the top, 4 over 3 on the top, 4 over 3 on the bottom, a pi on the top, a pi on the bottom. I'm left with 109 to the third times r to the third. Why? This is this rule, right? We distribute the third all over r to the third. And I'm not going to deal with that because they go away, right? I have 1 on the top, 1 on the bottom. I can reduce. All I'm left with is 109 to the third. And the book says, and your calculator would say, it's 1,295,029. This is how much bigger the volume of the sun is compared to Earth volume. Okay. 2 things we had to know here. This formula, which you can use that common formula sheet for your tests, that is your cheat sheet. You can keep it close by. It would help you to memorize them for your ACT, but I don't care that you use them for the test. And then we were able to know I can reduce whatever I have on top on the bottom. I only had to apply one rule, and that was that distribution, reduce that, and plug it in the calculator. Now, quick review before we're done with 6.1 of scientific notation. Let's go ahead and play with 2 numbers. They don't even bother here to remind you how to do scientific notation. They just throw a word at you, but we're going to play with it. Let's say I have 1,250,000, and I'm telling you, write this as scientific notation. Remember, your decimal is here. We're going to move to the left. 1, 2, 3, 4, 5, 6. I can only have one number before my decimal. This becomes 1.25 times 10 to the, we counted 6, 6th power. That's how you do the positive scientific notation of the positive exponent. What if we have 0.00000032? Okay? How do I write this as scientific notation? My decimal now goes the opposite way, right? I'm here. I need to bring it to where I have one digit before the decimal point. 1, 2, 3, 4, 5, 6. I'm very consistent, apparently. This becomes 3.2 times 10 to the, we moved to the right, becomes a -6. This is a quick review. You've done scientific notation 3 years in a row. Now, how do we do it the other way? If I say 3.5 times 10 to the 5th, how do I get this? Well, I go 3, 5. My decimal is here. It needs to move to the right 5 times. I know that because positive number will give me a big number, okay? I go 1, 2, 3, 4, 5, 0, 0, 0, 0. There's my comma. It's $250,000. That would be a good amount to have right now. What if I have 1.2 times 10 to the -3? Remember, when you have a negative exponent, you want to start here. Your decimal is here. It's moving to the left. 3 points. 1, 2, 3. There's my decimal. So my number is now 0.0012. Quick reminder of scientific notation. I told you in class, and if I need to, I will attach the video from last year when we looked in depth at scientific notation. If you need to watch that again, or you maybe didn't cover it really well, if you didn't do it with me, I can attach that for you. Last example 4 that we're going to do on this 6.1, it has a word problem from Denmark, and it talks about the GPD, which is gross domestic product, and versus population. So here's what we know. Denmark has a population of 5284000, and it has a GPD of 131,400,000,000. I'm trying to make sure I got the right numbers down. Yes. They want to know per capita GPD of Denmark. That means they want to know what is the GPD divided by your population. How much is per person? That's what they want to do. We can't do it like this. We want to do it with scientific notation. So this becomes, my decimal is here. I go 1, 2, 3, 4, 5, 6. 5.284 times 10 to the 6. That's my population, right? The GPD gets from here. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1.314 times 10 to the 11th power, okay? That's the numbers we're playing with right now. So let's go ahead and write it down. GPD, 1.314 times 10 to the 11th over 5.284 times 10 to the 6th. Now remember, I can separate this because we said in scientific notation, we do numbers with numbers and bases with bases. So I don't know what that is, but this is 10 to the 11 minus 6. This is this, right? So this is to the 5th power. And now we're going to take the calculator and going to do 1.314 divided by 5.28. If you do this, this is going to be 0.294 times 10 to the 5th. Remember the rule of scientific notation? You have to have one digit before the decimal that's not 0. Right now it's 0, which means I have to move this way one time, right? This becomes 2.94 times, I moved to that side, right? Did I write this the wrong number? Have I lost my mind? Oh, they actually want the number. I'm not opposed to this. 10 to the 6, because I moved that to one right, so I get 1 to the 4th. Sorry. This is the opposite. This becomes times 10 to the -1 times 10 to the 5th, right? We moved it once, times the -1. When you add them, this is 2.94 times 10 to the 4th. You can also write this as 29,400 if you need to, okay? And this is how you do this problem. Please never leave it like this. You need to make sure either to finish it, put it in the calculator, as you see it and get your number out, or move your decimal ones to where we have a scientific notation. We always have to have a digit that's greater than 0 before your decimal. And that's about 6.1. Good luck with all of the division rules, exponent rules, and we'll see how you did.